Problem 22. Circle 1 and circle 2 each have radius 1, and the distances between their center is 1/2. Circle 3 is the largest circle internally tangent to both C1 and C2. Circle C4 is internally tangent to both C1 and C2, externally tangent to C3. What is the radius of C4? So we can let's extend this line like this, and then we know this is also going to be 1/2, right? Because, and then this line here would also be 1/2. Why? Because if you look at it, like, we're told that this is the center of circle 1, and this is the center, this is the center of circle 2, right? Well, then the radius is going to be from here. The radius of circle 1 is going to be from here to the center, like that, right? And then 1/2 is going to be half of the radius. So then we know all the other sides are also 1/2. Okay, so now we can extend a line from the midpoint of this line segment, this 1/2 line segment, to the center of circle 4. I'm going to use red to represent the radius of circle 4, okay? So this is the radius. And then we can extend another line from here to here. Okay, so here in this line we have two radiuses. We have one radius here and two radiuses. So basically we just did a diameter. This line is just a diameter plus this black line, okay? Well, firstly, what's the measurement, like what's the length of the base of the triangle? Well, the base is just 1/2 of 1/2, so it's just gonna be 1/2. So the radius, so the base is gonna be 1/2 divided by 2, which is equals to 1/4, right? Okay, so we know the base of the triangle is going to be 1/4. Well, what's the height going to be? Okay, so we know this length here, like the length from here to here is the radius of circle 3, right? And then we know the radius of circle 3 is also this length here. So then we know the radius of circle 3 is going to be 1/2, which is here, plus the length here, which is half of 1/2, which is 1/4. So the radius of circle 3 is going to be 1/2 plus 1/4, which is equals to 3/4, right? So now that we know the radius is 3/4, then this length here is just going to be 3/4 plus r, because it's also extended to the center of circle 4. So we also added the radius of circle 4 onto this length here. Okay, now what about the hypotenuse of this triangle? What's going to be the length of the hypotenuse? Well, we can see the hypotenuse. It's going to be okay, so we know that the radius of circle 1 is 1, right? As we told here, the radius of circle 1 is 1. Well, if we look like here, this length is also radius of circle 1, right? So then we know that the black line, so the black line segment plus the red line segment is going to be equals to 1. So then the length of this whole segment is going to be 1, right? But but as we can see, we extended the we overextended the line. Like, look at this radius here. We overextended it by this little radius here. So the length of this line is actually going to be 1 minus r, because we need to minus out that overextended radius. Okay, so now we can get rid of this radius here and we can have a perfect triangle. And this length here is going to be 1 minus r. Now we can just use the Pythagoras theorem and we can solve for r. So r plus 3/4 squared plus 1/4 squared equals to 1 minus r squared, right? So solving this equation, we get r is equals to 3/28. So answer is choice D.